Greetings from Mahajabeen. I'm from ECE College, IRA, and I'm going to discuss some sources of dynamic power. I'll take just 5 to 10 minutes of yours. Thank you so much. Dynamic dissipation. It is due to charging and discharging load capacitances as a gate switch. Short circuit current while both PMOS and NMOS are partially on, which makes a formula like P dynamics equals to switching plus P short circuit. Static dissipation. It is due to threshold voltage leakage. Threshold leakage through of transistors. And also due to gate leakage through dielectric, junction leakage from source or drain deficiency, and it makes a formula P static is equals to I sub plus I gate plus I junction whole into V voltage. So P total is equals to P dynamic plus P static. Now we discuss some information on some on design of low power. So it is divided into four subtopics: power and energy, dynamic power, static power, and low power design. We start from power and energy. Power is drawn from a voltage source attached to VDD, which is in the chip, and instantaneous power is equals to IDD into T into VDD. Energy is as given, average power is also as given. And dynamic power, what is dynamic power? It is required to charge and discharge load capacitances when transistors switch. One cycle involves a rising and falling output. On rising output, charge Q is equals to CVDD is required. On falling output, charge is dumped to ground. This repeats TFSW times over an interval of T. As it is given in a figure, here we have two ground. One is connected to the direct transistor and other is connected to capacitor. Dynamic power, and here it is as shown here. It is the derivation of dynamic power, and where T is time, VDD is voltage, and now activity factor. uh, F is equals to frequency, we suppose clock frequency, and let FSW is equals to alpha F, where alpha is activity factor. If signal is a clock, alpha is 1. If signal switches once per cycle, alpha is half. Dynamic gates switch either 0 or 2 times per cycle, alpha is equals to half. Depends on design. Static gates depends on design, but typically alpha is equals to 0.1. Dynamic power, P dynamic is equals to alpha CVDD whole square into F, where F is the frequency. Short circuit current, when transistors switch, both NMOS and PMOS networks may be momentarily on at once, leads to blip of short current. Less than 10% of dynamic current is rise or fall times are comparable for input and output. For example, 200 m transistor chip, 20 m logic transistor, average width is 12 lambda, 8 m memory transistor, average width is 4 lambda, 1.2 volts of 10 nanomilli process. These are the some examples of dynamic, and where activity factor is 0.1 for CMOS logic gates, static CMOS logic gates. Memory arrays, for this activity factor is 0.01, 0.05. It is explained some deeply. Static power. Static power is consumed even when the chip is quiescent. Ratioed circuit burn power is fight between on transistor. Leakage draws power from nominally off devices. ratio example. Here are some examples. Chip contains 32 word into 48 bit ROM, uses pseudo NMOS decoder and bitline pull-ups. On average, one word line and 24 bit lines are high. Find static power drawn by ROM. And we find the static power here, and we get P static is equals to 1.6 milliwatts. Here are some leakage examples. And low power design. Reduce dynamic power. Alpha is clock gating or sleep mode. C is small transistor short wires. VDD is lowest suitable voltage. F is lowest suitable frequency. Reduce static power. Selectively use ratioed circuits. Selectively use low VT devices. Leakage reduction. Stacked device. Body bias. Low temperature. I got this from internet, some newspapers, and some magazines. Thank you.